This tree ring, yeah, this one right here, just gave scientists a huge wake-up call about the dangers that solar flares pose to civilizations. And more importantly, just how poorly prepared humanity is for the next time one happens. But first, before we can answer why a solar flare is so dangerous to human civilization and why a tree ring would have anything to do with it, we first have to understand what a solar flare even is. See, the sun is essentially a giant, nearly perpetual nuclear fusion reactor. And under extraordinarily intense gravitational pressure and high temperatures, hydrogen molecules are continuously being fused together to create helium molecules. And this active fusion creates an enormous amount of energy. Contrary to how our nuclear fission reactors work, where we're splitting apart large, unstable molecules, fusion reactors are mashing small molecules together. And fusion releases much more energy than fission without the harmful byproducts that we get when we split isotopes of uranium or plutonium. And that is why Doc Ock was so obsessed with creating a miniature fusion reactor in Spider-Man 2. Clean, virtually limitless energy without any of the radioactive waste.
The power of the sun in the palm of my hand.
But as Doc Ock learned, power like that isn't easy to control. And he also got a pretty good look at what a solar flare looks like. A solar flare is essentially a massive spike of electromagnetic energy that occasionally erupts from this extremely powerful fusion reaction. Now, the fusion reaction that Doc Ock ignited was small enough to fit inside of a Manhattan loft apartment. But now imagine that the sun, which is essentially just one big fusion reaction that you could actually fit 1 million Earths inside of, has an electromagnetic spike like that. That kind of energy release has the ability to completely disable our electronic capabilities worldwide. We're talking satellites, telecommunications, power grids, essentially everything we now require to communicate would just get shut off. And the crazy thing is, this has happened before, or at least on a pretty small scale. Now, for those lucky enough to have seen the Aurora Borealis, or commonly known as the Northern Lights, you've had the privilege of seeing a spectacular light show. But what you may not know is the Aurora Borealis is actually caused by the Earth's magnetic field redirecting radiation from the sun towards the Earth's poles. But in August of 1859, a solar flare sent a burst of electromagnetic energy to Earth that was so powerful you could see the Aurora Borealis from Florida. And a few days later, another pulse of electromagnetic energy hit the Earth in the middle of the night that was so powerful that the Northern Hemisphere actually lit up as if it were daytime. This event was observed throughout the Northern Hemisphere as far south as Central America. It was later called the Carrington event after the English astronomer Richard Carrington, who observed a couple of sunspots during the event and linked the two together. And while all this was happening, no one was able to communicate via telegraph, because back in 1859, telegraph cables were about as complicated as our electric grid was, but even they got completely fried with electromagnetic surges that rendered them inoperable. And one can only imagine what kind of effect this would have today. Virtually every aspect of our lives are now controlled by what happens on a computer screen. A large enough solar flare comes along, and not only are you not able to watch any more of my fantastic videos, please subscribe, but virtually every aspect of your life is going to be impacted. Grocery stores wouldn't be able to deliver shipments on time. Gas pumps would be down. You'd be without power for potentially weeks, maybe even months. We would have to launch new satellites for Google Maps to work because all of the satellites in orbit would get fried.
I drove my car into a lake.
It's hard to even imagine at the scale with which we now rely on electricity, just how big the impact would be if the power was just shut off worldwide simultaneously. But it's generally believed that another event like the Carrington event would result in trillions of dollars in damages. And here's the other scary part, there's not a whole lot we can do about it right now. See, it only takes light about 8 minutes to travel from the sun to the Earth. So that's about all the warning we're going to get. If everything goes according to the best laid plans, all we're going to get is an emergency broadcast that says, hey, in a few minutes, nothing's going to work anymore. But being the ray of sunshine that I am, pun intended, the good news is that Carrington events only happen about every 500 years or so. And storms about half the size of the Carrington event happen around every 50 years, and these typically don't do too much damage. But what about solar storms larger than the Carrington event? How often do those happen? And the answer is, more often than you think. And researchers have found at least part of the answer to those questions in fossilized tree rings. Researchers have found a strange spike in radiocarbon within the rings of subfossilized trees in the French Alps dating to around 14,300 years ago. Radiocarbon is constantly being produced in the upper atmosphere by a chain of reactions initiated by cosmic rays. Generally, the sun and the Earth's magnetic field help shield us from the constant bombardment of these galactic cosmic rays, so that normally when the sun is more active, we get less radiocarbon being produced. However, in 2012, Fusumiyaki discovered a sudden and unexpected spike in radiocarbon levels in a Japanese tree from 774 AD. Initially, this was thought to have been caused by supernova, but after more study, it was instead identified as being due to a huge solar storm on the sun. Now here's the great thing about science. When you're doing it correctly, you can often find supporting evidence in some unlikely places. We checked our 14,300-year-old radiocarbon spike by comparing it with beryllium-10 found in Greenland ice cores. Beryllium-10 is another chemical isotope that is produced in a very similar way to radiocarbon. The fact that the 14,300-year event was supported by both the radiocarbon and the beryllium-10 indicated that the massive production spike we found was genuine and not noise. It also supported the solar origin of the event, i.e. a massive solar storm considerably bigger than any previously identified. But how much bigger are we talking about here? The Carrington event that we previously discussed is not identifiable by looking at past radiocarbon in trees. It wasn't even big enough to leave a significant trace in the radiocarbon record. It's thought that the Miyake events are an order of magnitude bigger than the Carrington event. Our 14,300-year-old storm is the biggest of all the Miyake events discovered so far, twice the size of the eponymous 774 and 993 AD storms first found by Fusa Miyake, so at a guess, at least 10 times larger than the Carrington event. Now here's where the article leaves it open-ended. We don't really know how resilient our current technology is to such huge events. This is the really big question. Will our communication, electricity grids, and satellites mostly be able to withstand the impacts of such a storm and just suffer temporary effects before quickly coming back online? Or will they catastrophically fail? So imagine that. We have evidence in fossilized tree rings and confirmed by evidence taken in a different part of the world in ice cores from Greenland that these solar storms are actually a lot more common than we previously thought. And not only are they more common, but they have a far greater destructive capacity than we originally thought possible. So maybe some of these doomsday preppers storing canned goods in their basement are starting to sound a little bit more rational. But at this point, I would love to know what you guys think. Do you think this is even something we need to worry about in our lifetimes? Or are you already on the way to Costco to stock up on toilet paper? Let me know in the comments below, and I will catch you guys on the next one.